Okay, this is part 2 to the series Am I Ready for Math 104, Calculus 2 at Penn, called Calculus 1 at Penn, but it's Calculus 2. And we are going to look at question number 6 here. A ball is thrown into the air and the velocity is equal to 80 feet per second. The position, velocity is a function of time. Oh, and actually, it seems like velocity is constant. Okay, great. The position is a function of time, and it is 80t minus 16t squared. You don't have to worry about where these formulas are coming from. We just have to be able to use them to answer the question. They give us a great hint. It will be at maximum height when its instantaneous velocity is 0. That might be something in the future that you just have to know, or something that you should know from a physics class. And so they're asking us to find its average velocity from the time it is thrown to the time it reaches its maximum height. So there's lots of things going on. There's average velocity, there's instantaneous velocity. These are two different concepts, instantaneous velocity and average velocity. And so let's first find the time it takes to reach the maximum. Let's take the derivative. Yeah, this is the initial velocity, sorry. Sorry about that. Initial velocity is that. And so we take the derivative. S prime of t is the velocity. It's a function of time. And it is the 80 minus 32t. And what we're going to do with this is set this equal to 0 and solve for t. 80 would be equal to 32t, and divide by 32. And t would be equal to 80 over 32. Reducing that down by a factor of 8 at first, we'll see that we get 10 over 4. We can go even further. 16 goes into both of these. But now we just take the 2 out of these guys and get 5 over 2. At 2.5 seconds, you'll reach your maximum height. Your velocity will be 0. And so we have time t equals 0 and time t equals 2.5. We have they want us to calculate average velocity. And so the way we're going to do that is recognize that instantaneous velocity is the derivative, S prime of t, the derivative of position, while average velocity is found by taking the position at time 2.5 minus the position at time 0 and dividing it by the difference in time. And so how tall is it when it reaches that maximum height? We have to plug in 2.5 into your position function. 80 times 2.5 minus 16 times 2.5 squared. Without a calculator, it's better to use the fraction versions. 80 times 5 halves minus 16 times 25 fourths. Go ahead and square it. And so we're talking about 200 minus 100. So we get 100. That's the position at time 2.5. The position at time 0 is 0. And so your average velocity will be 100 over 2.5. A couple ways to deal with this. You can turn the 2.5 into 5 halves. 100 over 5 halves. And turn it into multiplying by 2/5. And so we end up with 40. The units will be feet per second. That's your average velocity over that 2.5 second interval from time 0 to time 2.5. That's your answer to number 1. That took a little longer than expected, sorry. Find the slope of the tangent line to the curve y equals 1 over 1 plus 2x at this point. This particular function, you don't have to treat it as a quotient rule to take the derivative. What we can do is bring it up as a -1 exponent, and we can do a power chain rule to take the derivative. Bring down the -1, make it 1 plus 2x to the -2, and don't forget the chain rule. Take 1 plus 2x's derivative and multiply by it. And if we can, we want to be able to put it back in the form of positive exponents when it's time to evaluate. Negative exponent is good for taking the derivative and taking the antiderivative, but when it's time to evaluate, it's better to have positive exponents. And so they want this when x is equal to 1. And so we just plug it in. And we'll have a -2 on top of 3 squared. So -2/9 is the answer to that question. We have the arctan of 3 log x. If your function is the arctan of x, your derivative is 1 over 1 plus x squared. Now, what if you have the arctan of an entirely different function other than x, something more complicated? Then to take the derivative of that, you start off with the same kind of concept, 1 over 1 plus, but instead of x squared, we take that whole function and square it. But then chain rule says that we need to multiply then by the derivative of that function. And so that's what we use here. If f of x is the arctan of 3 log x, then its derivative will be 1 over 1 plus that entire function unchanged squared, and then we multiply by the derivative of that function. Log x's derivative is 1 over x, so 3 log x's derivative is 3 over x. And they'd like for us to plug in e. So we'll have 3 over e times the quantity of 1 plus 3 log e, who gets squared. The log of e is 1, and 3 squared is 9, so we have 3 over e times 1 plus 9, or 3 over 10e. Letter G. Okay, find the absolute minimum value of a function on some interval. We learn that it's either going to occur at the endpoints or possibly any critical points in between. And so we make a chart of values starting with the endpoints. We take and evaluate the function at those endpoints. If we plug in a -3, we're taking a -3 and cubing it, taking a -3 and squaring it, multiplying a -8 by a -3, and adding on 5. That is a -27 plus a 9 plus a 24 plus a 5. These positive guys together are 38. And then when you take away 27, what you end up with is 11. The function at 2 is just 2 cubed and 2 squared and -8 doubled and add on 5. And so we get 8 plus 4 minus 16 plus 5. The positive guys add up to 17. So when we take away the 16, we get a 1. Now, the extreme value either is going to occur at the endpoints or at any critical point in between. So critical points come where your derivative is equal to 0 or where your derivative is undefined at. This is a polynomial. It has a derivative that is defined everywhere. We take the power rule to each part and we end up with 3x squared plus 2x minus 8 is our derivative. And what we're interested in is setting this equal to 0. Hopefully it's something we can factor, not guaranteed, but if it is, that would be great. And so we have 3x and x. Most likely it's going to be 4 and 2. And to end up with a positive 2, we're going to have to put the 4 there and the 2 there, with a plus in front of the 2 and a minus in front of the 4. And that gives us exactly the 2x, because we get a 6x minus a 4x. So that works out well. So 3x minus 4 is 0. if you have two guys multiplied to be 0, one of them has to be 0. So we set them both separately equal to 0. We get x is 4/3, and we also get x is -2. It's our job to plug these guys in if they're in our interval. Our interval is from -3 to 2, so yeah, they're both inside of there. We have a -2 and a 4/3, just fits inside. So what is the function at -2? Well, you take a -2 and cube it, take a -2 and square it, take a -8 and multiply by a -2 and add on 5. That's a -8 plus a 4 plus a 16 plus a 5. And that's a 25 on the positive side. Take away 8 from 25, and what you get is 17. So that's a 17 when you plug in a -2. And then unfortunately we have to plug in 4/3 without a calculator. And so we take 4/3 and we have to cube it and square it, and then multiply by -8, and then add on 5. It's quite unfortunate, but that's what it is. What we could do is factor out of 4/3 maybe from this first part, and be left with 16/9 plus a 4/3 minus an 8, and then we add on 5. Let's see what we can do with that. Common denominator would be 9. So we'd have 16 plus 12 minus 72 all over 9. And the 4/3 on the outside. And that's going to be, what? Add these together, get 28. 72, take away 28. It's unfortunate you got to do these side calculations here, but anyway, old school since you don't have a calculator. And we get 44. Yeah, -44. And then, so we're looking at a 4 over 3, a -44 over 9, and add on a 5. 27 times 5, because the common denominator is going to be 27 here, and 44 times 4. Sorry about these nasty calculations. 5, 3, that's 135. 44 times 4 is 176. We're going to have a -176, add on a 135, and it's all over 27, and I believe that's 41. Negative. Yeah. -41 over 27. That is your minimum value, and it's absolute on that interval. It's the smallest value that will occur. It occurs at a critical point in between, and that's what we're looking for, the absolute minimum value. The absolute maximum value would be 17. But it could have, these guys could have occurred at the endpoints. All right. I guess we should do one more. This video is getting kind of long, but let's see what we can do here quickly. Rewrite your function as x squared minus 1. Now this cube root, this means cubed root. Okay, it's not a square root. It looks like the square root symbol, but the 3 in there means it's a cube root. And that symbol does you no good when it's time to take a derivative. What we need is the fractional exponent that it stands for. And so that's 1/3 power. So we'll do the power rule by bringing the 1/3 down, taking x squared minus 1 to the 1/3 minus 1, and then multiplying by the derivative of the inside, which is 2x. And so what we have is 1/3 of x squared minus 1 multiplied, raised to the -2/3, and then multiplied by 2x. That is your derivative at any value of x. We are interested in your derivative at 3. What we could do is call this 2x over 3 times x squared minus 1 to the 2/3. Put it on the bottom. Negative exponents help you with the derivative and the integral, but when it's time to actually evaluate, it's best to have positive exponents. And so we put that -2/3. Handle that by putting it on the bottom. So we're talking about 2 times 3 on top of 3 times 9 minus 1 to the 2/3. So cancel your 3's. 2, and we have 8 to the 2/3. Okay, but 8 is 2 cubed. And so these 3's cancel. That's really a 4. And the answer would be 1/2. 2 over 4, which is 1/2. Okay, sorry this video took a little longer than the last one, mostly because of that word problem in the beginning, but that's part 2, and we're halfway through the review.